So today we are going to talk about the lecture 9 in CMP 270, which is Laplace transform and system transfer function HS. So last lecture we talked about impulse response, step response, ramp response, which is the basically, what if the input is the unit impulse, unit step, unit ramp, how will the system respond to the signal? And the causal LTI system is ht equals to t when t is less than 0. And the output of the LTI system is the output of the LTI system is the cascadeless LTI system is that can be implemented in any order. And in this week, we're going to talk about the Laplace transform. The transfer functions is the Laplace transform of the impulse response. So, let's talk about the impulse response. The impulse response is the response to the output to the input unit input. This will allow us to find the system response by any input xt. That is the xt. What if we know the impulse response is ht? We can know what if the input is xt. Then it is just the ht convolution with xt. It will give you the system response for any given xt, which is yt here. And the just as illustrated in this slide, and the ht is just the impulse response. And the transformation is that we want to avoid doing convolution. We want to avoid doing the integral. We just want to what if the problem is originally stated in one way, but we can do a transformation and the solution solve the solution in the other domain and inverse transformation and come back. So the problem in the time domain will do the Fourier transform, solve them in the frequency domain, and inverse Fourier transform and solution in the time domain. And we can do the frequency in the time domain and do the Laplace transform solution in S domain, do the inverse Laplace transform, get them in the time domain as well. And because in the time domain we are going to solve the linear differential equation, which is difficult, and then we can do the Laplace transform and we can do the simple algebra and inverse them back to the time domain. That's very interesting. And this is kind of engineering thinking. So what is Laplace transform? Laplace transform is LFT, which is LFT, which is fs, which is the integral from 0 to infinity. This is worth noticing that we are talking in this module. We are talking about one side Laplace transform. Therefore, it is integrating from 0 to infinity, and ft times e to the power of minus st and with dt, and the inverse Laplace transform is defined as the L minus fs to the power of minus 1, which is equal to ft, which is equal to 1 over 2 pi g. We are integrating from omega minus g infinity, and to the omega plus g infinity, and we get the fs e to the power ts ds. And another thing, we have any other common Laplace transforms, which is all defined for t is greater or equal to 0. And for example, what if the ft is equal to 1, the fs is equal to 1 divided by s? What if ft is t, the fs is 1 divided by s squared? And what if cosine omega t is equal the fs is s divided by s squared plus omega squared, and the impulse response is going to, what if we take the Laplace transform of the impulse response? We are going to get the transfer function of the s. The transfer function hs is the Laplace transform of the impulse response ht. the HS is a complex function where the S equals to J omega, X equals to J omega is very important, which is linked between the Laplace transform and Fourier transform. And the XS corresponds to XT, and the system will HS corresponds to HT, and YS corresponds to YT. As it's noticed that the convolution in the in the time domain is corresponds to the multiplication in the frequency domain. Therefore, we are going to define the HS to be the Y. This one we are going to. This is the convolution since it's the multiplication in the frequency domain. Therefore, HS can be defined by the YS divided by XS. And finding the output is just the HS times the XS. Therefore, this is what we learned today. And generally, we use the table to find the corresponding one. Okay, that is all for today, and we are going to talk about the lecture 10. The lecture 10 is thank you very much.